I've come on today to talk with you about space and the variations on space that have been proposed over the course of history by many great physicists, some of which are written here on this board. I've called it blank spaces not only because I'm a big fan of Taylor Swift, but also because there are seemingly some gaps in the theories that haven't quite brought together what we need to know about how space-time actually works. So, what I've written here is a collection, as I say, of physicists who've contributed so far to the thoughts and theories on space-time. And space, essentially, let's take time out of the equation for a moment. And let's start with Euclid, who's first on the list. Euclidean space is essentially a division between matter, or the objects within space, and space itself. So in Euclidean space, for instance, this lamp has a format of its own that occupies a particular part of space, and the space around it is separate from the lamp. If you look at Minkowski space, it's a bit different. In Minkowski space, all the convergence of the matter, the materials, the objects, and the space around them are brought together because you add time as an extra dimension. So you bring the whole thing together into a congealed format, if you like. De Sitter space, well, that's a geometric mathematical manifold, really, describing space as an object of geometrical design. So if you want to look up those three for starters, that would be a good point to start from. Right, Boltzmann. He of Boltzmann's brains brought an interesting kind of consciousness element into the construct of space, which is well worth looking up. And de Broglie, well, Louis de Broglie is a French physicist of high repute in very noble status, in fact, had a bit of a hard time of it, but essentially he came up with wavelengths to describe what happened within space, and it's also very interesting to research. Everett, Hugh Everett, he of Everett's interpretation, came up with the concept essentially of the multiverse, or the many worlds theory, which went head to head with the Copenhagen theory, or the traditional classical theories of physics, and they still go head to head today, so no change there then. But look up Everett and Everett's interpretation for more on his theories on that. These two are assigned groups of theories. So there is the Lorentz group of theories looking at symmetries and invariants and various forms of ways of looking at the space around us. And then there's the Poincaré groups, which are also groups of theories covering various formats within the space continuum, as it were. So that in a nutshell is what we've got to play with here, and the blank spaces in between are kind of for you to fill in, which is the whole point of this video, really, to see what comes of it and what blank spaces you can find between those various theories, because there are lots of them, and there are obviously lots of thoughts also that can come together into the mix and create complementarities and similarities and, hey, maybe even singularities in there somewhere in the mix. These are then the brains of Everett's multiverse, and there is a thought bubble that could sit in the middle of them, and that's yours, as I say, to fill in as you wish. So have fun with this little exploration into space. Be an astronaut from your armchair and see what happens. You never know where you might take off to. Okay. These are the sort of topics we have fun with in the Quantumology group on Facebook, and so do come along there if you want to join in and take part in the live discussions. You can find us also, Quantumology, on .net and .org on your search engine. You can look us up on Twitter if you want to, and please feel free to acquire the book, which is available by Amazon or by me. So have fun with quantum, look after yourselves, and have a lot of fun with this, because essentially that's the best way to learn. Take care. See you later. Bye.